It says start by you. Let everyone know they're being recorded. So you are being recorded. Thank you very much and see you on Wednesday.
Okay, thank you. Good morning, ladies and gentlemen. Can you all see my screen?
Yes, sir, we can. And good morning to you too.
Okay. Now, my name is Namadzabo Kone. I will be handling the two lessons. Today's lesson will only be on differentiation. And then because differentiation is a lot, so we will finish up differentiation on Wednesday and then also do integration. So let me just maybe start with a little bit of rules for these lessons, which will be that you will keep your mics off when I'm explaining things. But if you feel that there's something that you need explanation on, you don't have to wait for me to finish. You must switch on your mic and start talking. Then I will stop and listen to you. Don't raise up your hand because I will not be able to see it because I'm on the PowerPoint that I'm going to be using for presentation. I won't see your hand. So you just switch on your mic and then ask your question or comment. And then after you finish, you switch it off. Um, now let's start. And I hope,
Sorry, sir. Before we continue, I just heard you saying we're gonna have another class again on Wednesday.
yes. So the thing is, I realized that there's about 16 questions that I'm supposed to go through with you guys. And I
Okay.
realized that if I go through with you, go through the 16 questions with you on one day, it will be some overload in terms of your concentration span and everything. So I decided let me just offer to do it in two sessions so that we get one session, we do things slowly so that you understand properly, and then go to the next session and then finish up the other 8 questions. That's the idea.
Okay, so what time will the class start on Wednesday, or are you gonna upload it on announcement since it wasn't included?
Yeah, no, after this lesson, she will send you an email that has got the link and the time. The time is from 6 p.m. to 8 p.m.
Okay,
on
no
when
problem.
this coming Wednesday.
Okay, thank you, sir.
Okay. All right. Now, I would like you to uh, note that your subject, some at the beginning, somebody said the integrations are very difficult and so on. Everything in this subject is not difficult at all. The thing is, you guys have got the information sheet. That is, I think that the only problem that you have is how to use that information sheet to get the answers, which is what I'm going to explain to you in this lesson and the next lesson that we'll be doing on Wednesday. So if you have got your information sheet next to you now or open somewhere, it will be helpful. But I will share the formulas in the information sheet and how you should be able to use them to answer the questions. Let's start. The first question that we will do will be, in fact, all questions in this lesson will be on differentiation. Now, we are having a question on your screen, which we are differentiating with respect to x, and it is y equals the square root of sine of 3x squared plus 5x plus 7. Now, when we get a question like this, we need to understand the meaning of the square root. And the square root means a power of half. So which means that this question would have come in this way if that the examiner decided to give it in exponential form. Now, when you get a question like this, there is a rule that is applicable to do this differentiation. And it is there in your information booklet. And the rule is the one that I'm showing now on your screen on your top right there. This is called the general power rule of differentiation, and it's a very powerful rule as well. We will be applying this rule throughout this lesson and even in the lesson that we will do on Wednesday. So I will not repeat showing you the rule, but this is a very important rule that you need to note. Let me explain how it works. It says if you've got y expressed as a function of x raised to any exponent n, this n is a real number. N can be negative, it can be positive, it can be a fraction, it can be a decimal. When you want to find the derivative of a function that looks like that, what you do in the derivative, you consider that whole function as x, like the way you do the normal differentiation. So you take the n, you multiply it in front or with the coefficient of the function, and from the exponent n, you subtract 1. But you don't stop there. You have to multiply now whatever you have done by the derivative of what is inside that square bracket. So it means that it is the normal differentiation, like you are doing a derivative of a variable x. You take the exponent, multiply it in front. From the exponent, you subtract 1. Then you multiply by the derivative of what is inside. And then you are done. That's it. So that is what we are going to do to our function y equals sine of 3x squared plus 5x plus 7 to the power half. Now our n in this case is half. So in our derivative, we will come here and take the half, multiply it in front, our f of x as it is inside the bracket, and from the exponent half, we subtract 1. When we subtract 1 from half, the answer is minus half. And then we must multiply now by the derivative of what was inside. So in this first step, I didn't do that derivative so that I don't apply two rules at the same time. So now that derivative of sine of x squared plus 5x plus 7, then you will go to your information booklet and look at how to find the derivative of a sine function. And what you will find that the derivative of sine is found as, first, you need to find the derivative of what is inside the sine. So which means that you need to find the derivative of 3x squared plus 5x plus 7 first, and multiply that by cos. Then this name sine changes to cos of 3x squared plus 5x plus 7, which is what you are seeing on your screen now. So the first part is exactly the part that we had, which was the half f of x to the power of n minus 1, which is the part on your left. Then now after the multiplication sign, now this 6x plus 5 is the derivative of what is in here. And there it is. And then the name changes now from sine to cosine of exactly the same thing. Then we are done. Then we are done. So what we just need to do, we don't leave, never leave an answer with a negative power. Always write final answers with positive exponents. And this is how you can do that. So, and then the 2 that you see at the bottom is from this half. And then this power of minus half, when it goes down, it becomes power of half. And power of half is the same as square root. So, and then this is the final answer. Is there any question or comment, or we can move to the next item? Since there's no voice, so I believe that you understood that one. Now we get to the next question. The next question says differentiate ln of square root of x squared plus y squared equals to x minus y. Now in this question can also come as find dy dx or find y prime, depending on the notation that they are using. But you can see that this is not any question where you have got y as the subject of the formula. It has got y on the left side, inside that ln, and it has got another y on the far right-hand side. Now, this is where you use what we call implicit differentiation. Implicit differentiation entail you to differentiate both sides and be able to isolate the derivative from your derivative. So when you look at the left-hand side is a ln. Now, whenever ln, because ln is a logarithm, whenever it is involved, you must never go and do differentiation immediately if you can still simplify. How do you simplify? You go back to log laws. Now, if you look at the left-hand side, you've got ln of square root, and you like in the previous example, the square root means power half. So the x squared plus y squared has got a power half. That can be simplified, because if we don't simplify, then our derivative will include a lot of more rules than we can if we have simplified. So to avoid using a lot of rules at the same time, which may be confusing, the best way is to first simplify logs to the simplest form and then start with the differentiation after you simplify log laws. So when we take that power half to become the coefficient, we will get an equation like you see on your screen. It becomes half ln of x squared plus y squared. And it is very important to put x squared plus y squared in brackets, because if you don't and you just write it as half ln of x squared plus y squared without brackets, it's something now different, because the ln is only on the x squared, not now including the y squared. So this value x squared plus y squared has to be put in brackets so that we know that this ln is operating on both x squared and y squared. The right hand side is still the same. So now this is still the given equation in a simplified form. Now we have to start differentiating. Now to differentiate this, the left hand side, we need the derivative of a log function, and it is there on your information booklet. How does the derivative of a log function goes? It goes like this. It says you take whatever is inside that logarithm, find its derivative, then divide that by the function of x as it is. So it means that to find the derivative of this log function, we find the derivative of x squared plus y squared, and then divide that by x squared plus y squared as it is, and we are done. That's how to do the derivative of a log function. So that is what we are going to see in the next step. Now on the left side before the arrow, on the left-hand side before the arrow, we found the derivative of what is inside that bracket. The derivative of x squared is the straightforward one. It is 2x that you can see there in the numerator, plus. Now the derivative of y squared now is a little bit different, because y is a function of x. So it is now that power rule that I've spoken about in the first slide. Now we apply that power rule on y squared. So we'll take the n, which is 2, multiply it in front, have y as it is to the power of 2 minus 1, which is 1, and we have to multiply that by the derivative of y. So that is why you see it is plus 2y times y prime. I think that a lot of people get confused when it comes to finding the derivative of y of a function, which is y in this case raised to an exponent. So this is the rule that we are applying here is that general power rule that I've explained in the previous slide. Then at the end, all over the function inside as it is in the bottom. Now the 2 that you see there before the x squared minus y squared, this 2 is from this half, that half that was outside. That is where this 2 is coming from. Now the right hand side, now the derivative of the right hand side is straightforward. It will be the derivative of x, which is 1. This is the 1 minus. Now y, because the power is 1, we don't really need, we can still say we are using the power rule. It will be 1 multiply in front, y to the power of 1 minus 1, which is 0. Y to the power 0 then is 1. That is why you only see y prime on the right side. Then from there, we just simplify. We go to this left side. We realize that the 2 terms on top, both of them have got a common factor of 2. If we factor that 2 out, it will cancel with this 2 at the bottom. And therefore, we get what we see on the right-hand side, which is this one. So we get x plus y multiplied by y prime all over x squared plus y squared equals to 1 minus y squared. What we want to find here is the derivative of y. So which means that now, from what we have here, because we've got y prime here and y prime on the other side, we're supposed to try and group only those factors that contains y prime. And we can only do that if we first multiply by the denominator, which is x squared plus y squared. So we're going to multiply both the left hand side and the right hand side with x squared plus y squared. And when we do that, the left-hand side now is x plus y times y prime, which is the numerator after x squared plus y squared cancels each other out. Then when we multiply x squared plus y squared to the right side, when we multiply that by 1, we get this x squared plus y squared, minus when we multiply it by y prime, we get this, which is y prime into x squared plus y squared. Now, somebody may say, why don't you multiply this minus y prime inside? Our ultimate aim is to isolate y prime. So which means that if we multiply it inside here, we will again factor it out. So that is why I didn't multiply. I left it outside like that. So now what we need to do is to group those that have got y prime together. So everything that has got y prime is going to the left side, and everything that does not have y prime is going to the right side. So this whole expression that has got a bracket will move to the left side. This y times y prime will stay here. This x will move to the right, and this x squared plus y squared will remain where it is, and which is what you see on the screen now. So now that we've got the y primes on the left and the values without y prime on the right, now we factor out y prime from the left-hand side. We take out y prime as a common factor. When we do that, we get something like that. Then what we are left with inside is the x squared plus y squared and the y, which is this one. After we factor out the y prime is outside there. Now the last step will be to divide by the bracket both sides so that y prime will be left alone on the left-hand side. And then that is the derivative of this function with respect to x, and the derivative is on the left-hand side. Is there any question? Nothing. So we move to the next question, which is I've been marking these exams for quite some time. I mean your exams, and I have seen this question in almost every question paper. I'm not talking about this one as it is a similar kind of a question. It may be e to the power of 3x in some question paper, multiplied by cos of x, divided by the square root of 3x minus 5, or something like that. But I have seen this, it's always there. But what I have realized is that a lot of people do not follow our advice, like the advice that I'm going to give you today. There are two ways of doing this question. One way is just going to find the derivative straightforward as we see the question. And that will entail, if you can see, we've got a fraction. So which means that in this fraction, we are going to use what we call the quotient rule of differentiation. But then when we use the quotient rule of differentiation, in the numerator has got a product of two functions of x. So we'll also use the product rule together with the quotient rule. And then when we differentiate the one at the bottom, because it has got a square root, so it will involve the general power rule. So we will also involve the general power rule in finding that in the same step when we are doing the quotient rule. And when we differentiate e to the power of x, is the derivative of an exponential function. It has got its own way of differentiation. So we will involve that rule as well. When we find the derivative of sine of x, it has got its own rule. So we'll go to the rule for sine of x. Can you see that if you differentiate this as it is, then it means that we are employing almost 5-6 rules at the same time in one step. And that can be very confusing. It can confuse me as well, although I've been doing this for a very long time. But so to avoid you getting confused, we always tell you, whenever you get this kind of an equation, always introduce logarithms. Put ln on both sides and now simplify the right side. It will be very simple for you to do this derivative after you introduce ln on both sides. But you guys don't. Some of you do not do that. They just go and try and differentiate. And you will see that even the marker the marker get confused because you will have a lot of things written at the same time. And you, as a marker, when I'm trying to look, I don't understand what you are doing. Sometimes you do the derivative of these things at the first step. Sometimes you don't, or you do it on the left hand side, on the right hand side when you are doing the quotient rule after the minus sign. You don't differentiate. You will differentiate in the next step. So it's very confusing, and you don't want to confuse the marker because the marker could have got marks to give you. So let me show you how hectic it is to do this differentiation as it is. I'm doing it for you now. And then we'll again do the same differentiation you do using logs so that you can see what I'm talking about. So let's do it the hard way first. And I'm doing it in red so that you must remember that you must not do it. So this is the quotient rule on this derivative. I will explain it piece by piece. The quotient rule goes like this. It says, you fix the one at the bottom. You let it sit as it is, which is this one that you see there. Then you must find the derivative of the one on top, which is what I've written here. I didn't do the derivative. I just wrote that we are going to do this derivative so that we don't get confused about using all these rules at the same time. Then minus. Fix the one on top. The one on top remains exactly as it is. There it is. And you find the derivative of the one at the bottom, which is that derivative that I've written there. And at the bottom, you write the square of what was at the bottom. Now the square of the square root, then the square and the square root, they cancel each other out. And what is left is what is inside that square root sign, which is that one. This is just the quotient rule. Now in the next step, we are going to do this derivative. Now this derivative, as I have said, entails the product rule. And in that product rule, we will also have to remember the derivative of an exponential function and the derivative of sine. Then we will also find the derivative of this square root that is here. And this now will entail the general power rule of differentiation. And we are going to see it in the next step, which is this one. Now, this was fixed as it is. Now, this derivative is now the product rule. That is why we found now that we've got a 2e to the power of 2x, because when you find the derivative of an exponential function, it says you must first find the derivative of the function f of x on top. The derivative of 2x is 2, which is this one, multiplied by e to the power of 2x as it is. That is how the derivative of an exponential function works. Then that must be multiplied by this sign of x as it is, which is there, plus. Now, the e to the power of 2x is fixed. You copy it down as it is. Then you find the derivative of sine x, which is cos x, which is what you can see there. So we are done with this derivative. Minus e to the power of 2x as it is, sine of x as it is. Now the derivative of this square root. Remember, it is 1 plus x squared, all in brackets to the power half. Then when we find this derivative, the general power rule says we take the half, multiply it in the front. That is where this 2 is coming from. That half that I'm talking about, this is the 2 that was from that half. Then we must have that 1 plus x squared as it is, power of half minus 1. What is half minus 1? It's minus half. Then that minus half, we bring it down so that it becomes positive. That is where we get this square root of 1 plus x squared from. So the bottom ones are now covered. Now everything else must be multiplied by the derivative of what is inside. What is inside is 1 plus x squared. The derivative thereof, the derivative of 1 is 0. The derivative of x is 1, which is this one. The derivative of x squared is 2x, which is that one. So that is where we get this bracket from, which is the derivative of that one. Now you can see already it is a mess because we've got a fraction here over another fraction. You cannot leave any answer like this one. And you guys do that. And you sometimes you stop here and you say the answer is fine. You cannot stop here because you cannot have a fraction over another fraction. You need to sort that one out. And how do you sort this out? Because you see here we've got a square root at the bottom. You take this and you multiply by 1 of the form 2 square root of 1 plus x squared divided by 2 square root of 1 plus x squared. So you multiply by 1, which has got this as the numerator and this as the denominator. Now, when that 1 multiply, it must multiply both this and this terms, all of them. So when it multiplies this one, the 2 will remain 2 outside here. Now the square root of 1 plus x squared multiplied by this square root of 1 plus x squared, the powers of half will add to 1. So what will happen? You will have a 2 and in brackets 1 plus x squared only after you multiply that 2, this denominator here, when you multiply it with this part. So here we will have a 2 in a bracket 1 plus x squared. Now this bracket is sorted because it's multiplying this one. So then it now multiplies this side. The 2 multiplying this side will cancel with this 2. The square root of 1 plus x squared multiplying this side will cancel this one. So what will be left here will be this 2 that are outside together with that 1 plus 2x only. But remember, that 2 plus square root of 1 plus x squared must also multiply this one here at the bottom. When that happens, then it will be 2 outside, and it will be this 1 plus x squared to the power 1 multiplied by 1 plus x squared to the power half. Then 1 plus half is 3 over 2. That is now why you see something like that you see now on your screen. As I have explained, this 2 is from this denominator here, 2 square root of 1 plus x squared. And then the square root of 1 plus x squared times the square root of 1 plus x squared gives you 1 plus x squared, which is this one. This one, we just copied the whole of it as it is. There it is. And then the right hand side of this will be now, this one will be gone. It will have be cancelled out with the 2 and the square root. Everything will be gone. We'll be left with 1 plus 2x, which is what you see in brackets there. Now at the bottom, that 2 that I talked about is this one, and then the very same thing inside the bracket, power of 3 over 2. And now this is the answer, which can be written in simpler form by factoring out. What is the common factor here? We can factor out this e to the power of 2x sine of x. If we do that, if we take this one out, here we will be left with 1 plus 2x only. And here when we factor e to the power of 2x sine of x, this one will go and only 2 will remain. But here, we must also factor that out. So we must factor e to the power of 2x out and sine of x. Now it will become now cos x over sine x here, which will give you cot x. When you factor e to the power of sine x out and you put it outside here, and then you will have this in with that factor that is outside. But it's not necessary. You can leave your answer like this, and that is it. Done. But you can see it's a lot of things that we have done to reach to this answer. Now I want to do the same question if I introduce lean, and you will see how easy it becomes. So please, whenever you get a y equal to on the right hand side and you have got a lot of things that there's multiplication and division and everything, please do not differentiate it this way. Do it the way that I'm going to show you next. I am moving to the best way of doing this now. And then when we are done, we'll compare the two answers, because you will see that they will look very different, although they are the same. Now the same question. Now the first thing that we do, because we see the right hand side has got two things that are multiplied on top, the bottom has got a square root, and the only way to separate these things, write them properly, is to introduce ln, which is a logarithm on both sides. So if two values are equal, even their logs are equal. So that is why we are doing this. We said, because y is equals to e to the power of 2x times sine x all over the square root of 1 plus x squared, then their lns are also equal. That's the statement. Now, our right-hand side needs to be simplified. Now, when we simplify the right-hand side, ln on top, all values that are on top will have to be, their lns added together. So ln of e to the power of 2x times sine of x. It will be ln of e to the power of 2x plus ln of sine x. Then the one at the bottom, the log must be subtracted. So it will be ln of e to the power of 2x plus ln of sine of x minus ln of the square root of 1 plus x squared. But then, as I have explained, those lns on the right side, if there is still further simplification, we have to simplify further. We cannot stop. We must leave this in its simplest form. Now, firstly, we have got ln of e to the power of 2x. You know, there is that log rule of power that says if you've got ln of e to the power of 2x, that is the same as 2x ln e, and ln e is equals to 1. So ln of e to the power of 2x is the same as 2x. Then ln of sine x cannot be simplified, so we leave it as it is. Then we've got minus ln of the square root. That is, square root is power half. So that is the same as half ln of 1 plus x squared. That is the simplest form of the right-hand side, which is what you see there on the screen. Now, we have not started with differentiation. We were just simplifying our equation that was given. Now the derivative comes. Now, the three terms that contains ln will use the derivative of a log function. How does the derivative of a log function go? As we have done it in the previous question, you take whatever is inside the ln, you find its derivative, and you divide by that function as it is. That's it, and we are done. So, left-hand side, the derivative of y, which is y prime, that you see there on top, divided by y as it is. The derivative of 2x is 2. The derivative of ln of sine x is the derivative of sine x, which is cos x, divided by sine x. If you remember in the previous red example there, I explained something that I said it will be cot, which is coming from this cos x over sine x. You will see when we compare them that this is the same as what we had before. Then the last part is the derivative of what is inside, which is 1 plus x squared, and the derivative is 1 plus 2x, which is what you see there. And I think you remember that we had in brackets some 1 plus 2x there in the previous example. Divided by this 2 is the one that is from the half, there it is, and then it is multiplied by the function as it is, which you see there. And this is the answer. In fact, you just have to multiply by y, and you are done. That is the derivative. Now, if you remember your y is this thing here. If you can replace this y by this thing here, you will have the answer in the red example exactly as it is. Because if you can take this y, which is that one, e to the power of 2x times sine x over the square root, and you take and put it here, and you multiply it inside here. After you multiply it inside here, you will get exactly the answer that we got before. And I want to show you that now. This was the answer that we got before. The final answer was this one. Now, the answer that we got after we used the ln was this one. Now, we are replacing y by e to the power of 2x times sine x divided by the square root of 1 plus x squared. There it is. Now, let us take this and multiply it inside. We are taking this, we are multiplying it inside. When we take this and multiply it here, we get 2. We get 2 multiplied by e to the power of 2x multiplied by sine x over this square root. When we take this one and multiply it in here with the second term, remember cot x is cos x over sine x. When we multiply this inside, sine x will cancel with the sine x that is at the bottom. And what will be left here on top will be e to the power of 2x times cos x here, because this sin x will be gone. This is cos x over sin x, which sin x will be cancelling with this one. And what will be left here is e to the power of 2x times cos x over the square root here in the middle. When we multiply this with this one, we will get all this here multiplied by 1 plus 2x, which is exactly what you see there on top. And it will be over 2. This is power half, this is power 1, so it will be this power of 3 over 2 after we multiply this inside, which is what you see there on the screen right away. Now, what you see on the screen, if we add these three fractions, the LCM will be this one. That is the highest power of what is inside this square root sign. So which is this that you see there? The LCM is this one that you see here. And if we say, how many times does this go into the LCM, which is that one? We'll say this divided by this, and the answer will be 2 into 1 plus x squared. Because when you say this divided by this, you must say 3 over 2 minus half. And 3 over 2 minus half is power 1. So that is where you get this one from when you are adding these ones. So it means that this as denominator, when you are adding for this part, which is this here, you will get that. That is the first part from this one. Now, when we come to this one, we'll say this into that goes 2 into that inside power 1, and which is this one that we factor out, and we get that one that you see there inside there, which is this. That is the one there. Then this one into the LCM goes 1. Then whatever you see on top is whatever you see there. So these two answers are exactly the same. But it is hard to get the red option than to get the black option. So please stick with the black option of introducing lanes all the time when you get questions like this one. And as I have said, I've seen this similar kind of questions in each and every examination. So it may not be different from the one that you're going to write. You will find something that looks like this, and that's how you need to solve it. Is there any question before we move to the next question? No question. Then we move. Now we get given if xy plus x minus 2y minus 1 is equal to 0. Prove that 2 minus x squared multiplied by d squared y over dx squared minus 2y is equal to 2. Now, when you look at what we are supposed to prove, the meaning of d squared y over dx squared, it means it is the second order derivative. So which means what we need to do with what we are given, which is xy plus x minus 2y minus 1 equals to 0, we must find the first derivative. After we find the first derivative, we again go and find its derivatives, which will be the second order derivative. Then after that, we should be able to restructure the terms in whatever the answer that we have to look like what we have on the right-hand side. So which means that we must take what we are given and find its derivative. Now, when we find this derivative, xy is a product of two functions of x. So it will need the product rule. And the product rule goes like, we will find the derivative of x, which is 1, multiplied by y as it is, which is this y. Then plus, fix this x and multiply that by the derivative of y, which is y prime, which is this one. So these two terms are from xy. When we find the derivative of xy from the product rule, we get these first two terms. Then the derivative of x is 1, which is this one here. Minus the derivative of 2y is 2y prime. And then the derivative of minus 1, it's 0, equals to the derivative of 0 as well, it's 0 as well. So that is why we've got all this equals to 0. Now, our job is to isolate the first derivative, which means we need to move y and 1 to the other side first, which is this step. So after being left with x, y prime, and 2y on the left side, we factor out y prime, and inside the bracket, we are left with x minus 2. Then to isolate y prime, we divide by this bracket. Now, the first part is the derivative of y with respect to x, and it is minus y minus 1 over this bracket, which is x minus 2. So I just realized that we have got too many negative signs. So I decided, let's just simplify it by factoring out minus 1 on the top, and we factor out minus 1 at the bottom, and the negative signs cancel. And we get it as y plus 1 over now 2 minus x. Now, this was x minus 2. We have factored out minus 1. That is why now it has changed to that. Now, this is dy dx equals to y plus 1 over 2 minus x. So we need to now again find its derivative, the second now derivative of this y prime, which will be y double prime. And that derivative will entail the quotient rule because this is a fraction. So the quotient rule goes like this. We fix the bottom one. 2 minus x remains as it is, which is this bracket, multiply by the derivative of the one on top. Now the derivative of y is y prime, which is what you see there, and the derivative of 1 is 0. So we are done with this part. Then the quotient rule says minus here in between. It says minus here in between. But what we will have, if we have a minus here, we will have this one fixed, which is this bracket, and the derivative of this one at the bottom. The derivative of 2 is 0, and the derivative of minus x is minus 1. That minus 1 multiplies the negative of the quotient rule to get this plus here that you see there. So this plus is from the minus of the quotient rule multiplied by the minus of the derivative of this one at the bottom. That is where we get this plus from. Divided by the bottom one squared. The bottom one is 2 minus x squared. So now we have got now our second order derivative on the left side, which is what we will have to see sitting here according to what we're supposed to prove. And likely we can see we've got 2 minus x squared, which will multiply this second order derivative. And if you multiply everything by 2 minus x squared here, you get this part of our proof that we are supposed to show. So maybe likely on the numerator, we will get the minus 2y and the 2, and then we are sorted. But here in this proof that we are having, if you can check, there's no derivative dy dx or y prime. It is not there, but we have got it here. Now we need to remove it, and we remove it by putting into its place its equivalent. Now its equivalent is found here in the previous step. Y prime is equals to y plus 1 over 2 minus x. So we replace this y prime by this y plus 1 over 2 minus x. And this is what we have. Now, after multiplying by the denominator, we get this part, which I said is looking exactly like what we're looking for there, which is there. Now, 2 minus x multiplied by y prime. This is y prime now. It was replaced by its equivalent, which is that one here. And then plus y plus 1. Y plus 1 is after we remove the brackets, then we get that. So here, 2 minus x and 2 minus x will cancel out. And what is going to be left here is y plus 1 plus y plus 1. And what is y plus y? Is 2y. There you go. So this is where everything is coming together. 1 plus 1 is 2. There is the 2. So we are done. It's just a matter of now After this cancels out, y plus y is 2y. We take it to the left-hand side, and we get it as minus 2y. And we change this notation to write it in the other way. D squared y over dx squared. This just that as it is. Then we just leave the 2 on the right side. 1 plus 1, the 2, we leave it on the right-hand side. And now it means we have proved what we were supposed to show. And we are done. Is there any question? This question may come in various ways. They may not even say, show this thing. They may just say, find d squared y dx squared, for example. They give you this. They say, given that, find the second order derivative of this with respect to x. You do exactly the same thing. And when you come to this stage, you make d squared y dx squared the subject of the formula. So the answer would be, you take this one to the right-hand side, it becomes 2 plus 2y, and you divide by this, and then that's it. So if they give you this and they say, find d squared y over dx squared, then definitely you are supposed to first find dy dx. And you do it this way, and you find that dy dx, which is this y prime, is that. You do exactly the same thing, but then you just have to make d squared y over dx squared the subject of the formula, and you are done. If there's no question, we will move to the next question. And the next question says, we are supposed to differentiate y equals to arctan or tan inverse of 2x over the square root of 25 minus x squared. The derivative of arctan is there in your information book. You just go there and look at how the derivative works. Now, to make this explanation simpler for me, I've decided to copy it for you, and there it is. The derivative of inverse tan goes like that. It says, on the numerator, you find the derivative of the function f of x. And then you divide that by 1 plus the function of x squared. That's how that derivative works. Straightforward like that. So our f of x in this case is x over the square root of 25 minus x squared. That is our f of x. So it means that we need to find its derivative. Now, when you look at this, it is a function of x on top, another function of x at the bottom. It is the quotient rule. So which means we apply the quotient rule to find this derivative. Then after that, then the result is divided by 1 plus the whole of this squared, which is what you see here on the screen. And let me explain step by step. Now, what you see on the left side is the derivative of the function f of x, which is this. As I've said, it needs the quotient rule. And the quotient rule goes like this. It says, fix the bottom one, which is this, as it is, and multiply it by the derivative of the one on top. The derivative of x is 1. That is why you see this square root of 25 minus x squared sitting there as it is, minus the derivative, okay, the first one as it is, which is this x that you see there. Multiply that by the derivative of the bottom one. And the derivative of the bottom one is, the bottom one in itself actually is 25 minus x squared all power half. So that half must multiply it, we must multiply in front. And that 25 minus x squared as it is, power of half minus 1 is minus half, which is that one. That must be multiplied by the derivative of what is inside, which is the derivative of 25 minus x squared. The derivative of 25 is 0, and the derivative of minus x squared is minus 2x, which is this one. Then the 2 divides the 2. So the half here will cancel with this 2. The negative and the negative will multiply and will get a positive sign. And x multiplied by x will be x squared. All of this must be divided by the square of the bottom one, which is 25 minus x squared. That is out of this squared, which is that one. So this is our f of x. It is this part. Now this part must be divided by this one. So instead of divided by, I changed it to a multiplication sign. So we must say 1 over that. So that is why you see this as multiplied by 1 over. Because this division sign, when it changes to multiplication sign, it must be 1 over this thing, which is that you see there. Now it is 1 plus f of x squared. Our f of x, as I have said, it is x over the square root of 25 minus x squared. There it is. Then after we square this, we will have x squared over 25 minus x squared here. And when we add it to 1, it will give us something like this. I'll explain it piece by piece. Look at the left-hand side. The left-hand side before the other equal to the left side, which is this part here. So I want you to be able to join this together with what you see there and this together with what you see here. Let's start with this part. This square root of 25 minus x squared is this one. This plus here, it comes out of this negative times this negative, and it becomes this plus. This x squared comes from this x times this x. The 2's have cancelled, if you remember. The 2's are gone. Then because now this power is half, we rewrite it as a positive exponent. Therefore, this x squared will be over the square root of 25 minus x squared. It comes from this power of minus half, this one. And this is exactly that. So now you are aware of how these two are associated with each other. Then this one, let's associate it with this one. As I've said, here we will square, and we get x squared here over 25 minus x squared, because the square root power 2 is power 1. That is where we get this 25 minus x squared, this one. Now the numerator here is found from when we are adding this result here with the 1. Because this is over 1 here onto the LCM, it will go 25 minus x squared, which is this one. Plus, which is this plus, it is this one. Plus x squared, which is that x squared. That comes after when we said 25 minus x squared into 25 minus x squared, it goes 1. 1 times x squared is x squared, which is this one. So minus x squared plus x squared is 0. So in fact, this result here, this thing here, it is 1 over 25 over 25 minus x squared. If we remove this divided by and it becomes multiplied by, this becomes 25 minus x squared over 25, this one. 25 minus x squared over 25. And the 25 minus x squared on top cancels with this one. And we are left with 1 over 25 here, which is this one. Let me repeat here, I think. 25 minus x squared plus x squared minus x squared is 0. We are left with 1 over 25 over 25 minus x squared. Now 1 over 25 over 25 minus x squared. If we change this division sign to become a multiplication sign, it will be 1 multiplied by 25 minus x squared over 25, which is this one. Then that 25 minus x squared on top cancels with this one here. And what is left here is only 1 over 25, which is this one. Now, what you see there on top is what you see in here. Now, if we have to simplify that, it means we are supposed to add fractions here. So the LCM will be the square root of 25 minus x squared. Here it's over 1. 1 into the square root of 25 minus x squared, it's actually the square root of 25 minus x squared, which must multiply this one. When it multiplies this one, we get power 1. And inside, it will be 25 minus x squared, because half plus half is 1. Then plus on top x squared all over this square root. So on top we will have 25 minus x squared plus x squared all over the square root of 25 minus x squared. And minus x squared plus x squared is 0. So on top, we will be left with 25 only over the square root of 25 minus x squared. That 25 will cancel this 25. And the result will be something like that. So it is 1 over 25. Inside, it is that 25 that I have said, minus x squared plus x squared, which is 0 here, and 25 cancels out, and we get a 1 over the square root of 25 minus x squared. And we are done. I know you may not see that because of this band that is here at the bottom. I don't know how to remove it. Is there any question? If there is no question, yes.
I was saying that is understandable.
Understandable. Oh, perfect. All right. The next one. Differentiate y equals the square root of x tan. This is the hyperbolic function tan of square root of x. Now, this question is a product of two functions of x. It means, number one, you will need the product rule for you to be able to differentiate this, because this is a function of x and this is another function of x. Now, when you will need to do the derivative of tan, which is the hyperbolic tan, you will need a specific derivative which is there in your information book, and I have shared it with you there. That is how the derivative of tan go. It says if you want to find the derivative of tan of f of x, you must also first find the derivative of f of x as it is. Whatever is inside there is derivative. You need to find it, and then multiply that by such squared f of x, and that's it. So that's how simple this question is going to be. First step, the derivative dy dx equals, we find the derivative of square root of x first, which is that half x to the power of minus half, and we fix this one, tan square root of x remains as it is, and then we say plus. That is how the product rule works. So we fix this one, which is square root of x, there it is. Then we need, according to the derivative of tan, we need to first find the derivative of what is inside, which will be square root of x, and its derivative is the one that you see in brackets there, and then multiply everything by such squared of the very same function of x, which is square root of x. Then it's just a matter of rewriting everything with positive exponents and simplify. Now this one, it means we will have tan square root of x. And before I continue, another thing. There are people who may want to first start by writing tan square root of x and then multiply by this on this side. When you are writing an exam, it's a very stressful situation. The environment, the exam environment is stressful by itself. So that stress may make you see that square root of x is multiplying this thing, which is not correct, because this is multiplying the whole of this function. So this has nothing to do with what is inside here. So please avoid writing things like this. Even when we deal with logarithms, ln of something, write it last. Don't write it first, because if you write something after it, you may think that whatever is inside is multiplying that thing, which is wrong. So please avoid that. Write everything else first, and then whatever operator that has got a function of x last. Then you know that now this means that now we're going to divide by the square root of x here. So we will have that over 2 square root of x on this side in the final step. When we go to this one, this is x power half, and it is multiplying x power of minus half. Half minus half is 0, so this cancels with that one. So we are left with this half only, and then that's h squared. Also, in this case, you cannot write all these things in front here, because you may think that square root of x multiplies those things. So avoid that and write it like this. This is safer this way. And that is why you see your answer like that. And if we say write your answer in its simplest form, it means you must add these two. And if that is the case, then your normal addition process comes into play. You will have your LCM which is this one, which you put there, and you will say how much time does this go into that? It goes one times that, it is that. Then plus 2 into the LCM, it goes square root of x. Now square root of x multiplied by that gives you what is there on top, and this is the final answer. That's how simple these things are. I will show you the same thing, that it is simple to do integration as well, because it is that simple. You become difficult for these things. You have got everything in your hands. The formulas are given. Next question. If there's no comment or question, we go to the next one, which is this one. Now it says find dy dx if you given y cos y equals to x cos inverse arc cos x. Find dy dx from this equation. Now, here it means left-hand side, we have got a product of two functions of x. So it means that we are going to use the product rule on the left-hand side. While we are at that product rule, we will need the derivative of cos. Right-hand side. Also, a product of two functions of x. Product rule will also apply on the right side. But while we are at that, we will need the derivative of arc cos. So first, the derivative of cos goes like this. It's negative. That is the first thing. Multiply by the derivative of what is inside. Cosec squared of that function. That's how to do the derivative of that one on the left side. The derivative of the one on the right side is in yellow there. It says it is the derivative of the function f of x on top divided by the square root of the function of x squared minus 1. That's how the right-hand side one will go. So those are in your information booklets. You go and check them, but then you know, because we've got a product of two functions of x on other side, it needs product rule. And you apply the product rule in the first step. And that's what you get. One by one explanation. We start by the derivative of y, which is y prime. And we multiply that by cos y as it is, which is that one. According to the product rule, it says plus fix y as it is, put it there. Now the derivative of cos y, we go to the blue there, and we find that it is negative. That is where you get this minus. The derivative of the function f of x itself. The function f of x is y. The derivative thereof is this y prime. Multiply by cosec squared of y, which is this one. We are done with the left-hand side. Go to the right-hand side. Same thing. Find the derivative of x first, which is 1. Multiply by cos inverse of x, which is that one. Plus x fixed, which is this one. Now multiply that by the derivative of arc cos, which is cos inverse, and it is there in yellow. It says the derivative of f of x, or f of x is x. That is why the derivative is 1, which is this one, divided by the square root of f of x, which is x squared. There it is, minus 1. Then the only thing that we need is to isolate y prime, which is that dy dx that we're looking for. We isolate it, we factor it out. And after factoring it out, what is left in brackets is cos y minus y cosec squared y. And now the right-hand side, now we have added these two together. We have said the LCM is the square root of x squared minus 1. This is over 1. 1 goes the square root of x squared minus 1. That is why you see this here, cosh inverse of x, plus this one goes 1 times x is x. That is why you see the x there. Then the final answer, we divide by the bracket, this bracket on this side. So y prime, which is dy dx, is equals to that. And we are done. Guys, is there anything difficult here, honestly? Nothing. Nothing is difficult here. Let's go to our last question for the day. Our last question for the day says, if you are given x equals to 3 square root of t and y equals to 2t to the power of 3, find dy dx and d squared y dx squared. But here we don't have any y in terms of x. Rather, we have got x in terms of some other variable and y in terms of another variable. Then here we can find dy dx first by finding the individual derivatives. So we'll first find dx dt for the first equation. Then we can find dy dt for the second equation, which is what you see there for dx dt. This square root of t is t to the power half. So the derivative will be 3 multiplied by half, t to the power of minus half, equals to 3 over 2 square root of t, because we have written now this with a positive exponent, it must go underneath. Then we find dy dt. Our y is equals to 2t to the power 3, becomes 6t squared. Now we need to figure out from these two, how can we find dy dx? We can only find dy dx if you take this one and divide by this one. Because if you take dy dt and divide it by dx dt, dt and dt cancels and we get dy dx, which is what you see here on the left side. dy dx is equals to dy dt over dx dt, but we are not cancelling because we have got these values already. We've got dy dt 6t squared and we replace it there. We have got dx dt 3 over square root of t and we replace it there. And if we simplify this division sign becomes multiplication sign and we get 6t squared multiplied by 2 square root of t over 3. And 2 over 3 multiplied by 6 is 4, because 3 goes 2 into 6 times 2 is 4. T to the power 2 plus half is 2t to the power of 5 over 2. So this is dy dx. Now when we get problems like this, to find d squared y dx squared needs a method called parametric equations. You don't just go and do a d squared y dx squared here and you think that you can just go and find the derivative of this straight away. You don't do that. There's a formula on what we call parametric equations where you can find that formula, and that formula looks like this. It says d squared y over dx squared is equals to d over dt of dy dx divided by dx dt. Then it's just a matter of substitution here. In place of dy dx, we put our dy dx. We already have got it here. Stick it in here. Then here, you've got it dx dt, that one. You put it there. Then from there, you find the derivative of 4t to the power of 5 over 2. And then you divide it by that. Now the derivative of 4t to the power of 5 over 2, you will take 5 over 2 and you multiply it in front. When you multiply 5 over 2 by 4, 2 goes 2 into 4, 2 times 5 is 10. So you get 10. T to the power of 5 over 2 minus 1. Minus 1, which is minus 2 over 2 here, it leaves us with t to the power of 3 over 2. So we get this 10 t to the power of 3 over 2 from the derivative, divided by 3 over 2 square root of t is the same as multiplying by 2 square root of t over 3. Then when you multiply this, you will have t to the power, okay, first the numbers. 2 over 3 times 10 is 20 over 3. T to the power of 3 over 2 plus a half. 3 over 2 plus 1 over 2 is 4 over 2. 4 over 2 is 2. That is why you get t squared. So the derivative dy dx is 20t squared over 3. So if say you want to write this in terms of x, which I've seen that your lecturers do not mind for you to leave your answer like this. But if maybe you are required to write your final answer in terms of x, you go to the original equation and you have got your x equals to 3 square root of t. So you take 3 square root of t and you come and replace, you make t the subject of the formula here, sorry. Make t the subject of the formula here and replace t by the result which will be in the the following. X over 3 and you square both sides, so it will be x squared over 9. So you come here and you replace t by x squared over 9, and the answer in terms of x will be your d squared y all over dx squared. And this brings us to the end of today's lesson, and we will now continue with a few of the derivatives that we want to share with you that are left, and we will also do integration next week. Oh, not next week, this week, Wednesday. This Wednesday from 6 p.m. to 8 p.m. Please be there. And is there any question before we close the session? Switch on your mics, everybody. Mics on, please. Yes. Anyone who wants to comment? You don't have to raise up your hand. Just speak.
Yeah, that was a marvelous revision, Minier. I just want to say thumbs up, although I'm still also trying to go through what we've done to digest everything. I just thought I'm going to be the one to open the mouth. Thank you.
All right. Okay. Right, guys. Now, please, for mathematics is a very simple subject. Mathematics is like driving a car. If you go, those who drive a car will know. The first day you were sitting behind the steering wheel. After you have watched the drivers that were driving taxis and your cars, your friends, your parents, or whatever, you have watched them maybe over 1,000 times. But you have never driven a car. The first day you sat behind the steering wheel, then you started put the gear 1. The engine went off. But after you have done it 10 times, you can drive while you are drinking, while you are texting, you can drive and the car will not stall. That's the same as mathematics. Now, if these sections that we have done up to today, if you go if by Wednesday you have revised all these sections, you have done the questions on your own, there's no way in which you cannot make it.
So I was suggesting, how about you give us the last 8 questions that we'll do on Wednesday, and then we try them on our own and see if we are getting them by Wednesday when you do them with us.
I don't know them yet.
Okay, so I thought you had everything at once.
No,
Or we'll just revise.
I haven't prepared the next 8 questions, but the next 8 questions are from the next 8 sections. Dr. Dlamini can share with you the next sections that I am going to cover. Then you can go through those next sections. Then I will pick one of those questions and do them.
Okay, sir. Thank you.
Have a nice day.
The same to you, sir.
Okay, right. Bye-bye.
You don't stop it, it will just go on.